So, hello guys, this is the 15th day of I Speak and You Don't Judge, where I speak to improve my communication skills. So, yesterday was Sunday, so we had 2 days of gap from sessions, so it was good a bit and a bad a bit. So, yeah, yesterday in Codesai we discussed many things again. So, oh, by the way, myself is Ronak. I haven't told you, right? So, myself is Ronak, and Let's let me speak on some topic. Yeah, so on yesterday we learned the thing in AI which is perceptual learning, which is like we train our model to read text and images based on the feed value it assigns it, and in short, that's all. Let me try to explain that. So what happens actually is we have some input nodes and some processing layer, right? And there's then output node. So what happens is each node is connected to every processing node, and every processing node is connected to every output node. So what happens is we assign some weight to the input we are taking. We are currently training our model, so we assign some weights to when input we are taking. Like for if we scan an image, the blackened spot or the number it is written, the grid it is in, if it is black, we'll assign it some weight from 0 to 1, where 0 means nothing, 1 means absolute, like I got my result. So we assign some weight in input nodes. Input nodes then send it to the processing node. Processing node processes it and then sends out to output node. So what happens is output node, we already know the answer, so we put the answers in output node. Then we calculate which node got how much weight and see if how much they are close to 1. The closer they are, sorry, not 1, the output itself. The closer they are to output, the that will be our correct output. If we are not training, just checking the model if it is running or if we are training, what we do is if we get not exactly 1, we try always to achieve 1 to make our model better and better and better. So what happens if we don't get 1, we send back the data, reduce the weight of other nodes to make the my current node equals to 1, reduce the weight, change the weight, then rerun the whole thing unless until we get 1 as in our output node, the correct answer we have. So it it is something like equation of y equals to mx plus c, what from what I got. So where m is the processing matrix, x is the input matrix, and y is our output matrix, and the c here, the intercept here, is the bias. I will talk about bias in future. So it is bias, not future in this video. So it is bias. So what happens is we subtract the bias we have already from our input weight. Like suppose I have a bias of 10. That means my whole system is biased toward 10. So I subtract that much from all the inputs I am getting, then pass it to the processing layer, then process it, then returns it. So the formula is we can subtract and add both. So the formula become mx plus c, where I explained m is the processing matrix, x is the input matrix, and y is the output matrix, and x is the sorry, yeah, c is the bias we have. So this is called our perceptron or something. Yeah, I forgot the term. So it is maybe called perceptron. So it is denoted by sigma. Sigma, this thing. I don't know what we call this. So I forgot what I call this. So sigma, I guess. So sigma is a function which takes mx plus c, the equation we had, as input. So it, if you want to understand it, you can also understand it by that equation of a linear thing in matrix we do ax equals to b. So you can also understand by that. Also, we have input which is called not bias. It is called something like activation node. So every weight has its activation value based on it. It is activated or not activated. So that's all for today. Bye bye. See ya in next video. Until then, keep smiling, keep being happy.